Are we alone? I mean, it's pretty much the biggest question we can ask, right? And for basically all of human history, it's just been a question. But now, for the first time ever, we're building the tools to actually go find an answer. We're starting to peek into the skies of planets light years away. And honestly, what we're finding is shaking up everything we thought we knew about life in the universe. But that kind of begs the question, doesn't it? When we go looking for life out there, what are we really looking for? Are we just trying to find a mirror image of ourselves, another Earth 2.0? Or could life be hiding in forms and places so totally bizarre they'd make us rethink what life even means? So first things first, how in the world do you even find a tiny planet trillions of miles away that's right next to a star a billion times brighter than it is? I mean, it sounds completely impossible. But it turns out astronomers have a few incredibly clever tricks up their sleeves. To spot these distant worlds, we mostly rely on two amazing techniques. First, you've got the transit method. This is where we're basically stargazing, waiting for a mini eclipse. When a planet crosses in front of its star from our point of view, the star's light dims just a tiny, tiny bit. And from that dip, we can figure out how big the planet is. Then there's the radial velocity method. Get this. As a planet orbits, its gravity actually tugs on its star, making the star wobble just a little. It's a minuscule effect, but by measuring that wobble, we can calculate the planet's mass. And this is where it gets really powerful. Once you have the size from a transit and the mass from the wobble, you can do some simple math and figure out the planet's density. And that one number is our first crucial clue. It lets us sort the planets into two basic piles. Is it a dense, rocky world you could actually stand on, like Earth? Or is it a big, puffy gas giant, like Neptune? For a long time, the ultimate goal in astronomy was finding an Earth twin. But what if that was actually aiming too low? What if Earth isn't the absolute best planet for life? What if it's just good enough? Let's dive into this wild idea of planets that could be even better for life than our own. I love this quote because it just flips the whole search on its head. Think about it. For most of Earth's 4.5 billion year history, it was totally hostile to complex life like us. We're actually living in a very brief, very lucky window of habitability. It totally suggests that there could be other worlds out there that are way more stable and way more friendly to life over the long haul. And that brings us to this amazing class of planets called super-Earths. They're rocky, like our world, but bigger. And here's the real kicker. They seem to be the most common type of planet in the entire Milky Way. Our solar system is actually the weird one for not having one. So what's the recipe for a super habitable planet? Well, scientists have a checklist. A little more mass is great because it helps the planet hold on to a thicker atmosphere, kind of like a permanent blanket. It also keeps the planet's core hot, driving geology that recycles nutrients. Shallow oceans would be fantastic, letting sunlight reach all the way to the seafloor and fueling life everywhere. And of course, you'd want it orbiting an older, calmer star, giving life billions of extra years to get started and evolve. Okay, so we've looked at rocky worlds, bigger and better versions of Earth, but what if we throw that playbook out the window and look at something completely different? There's a whole new class of planets being considered that could dramatically expand the places we look for life. And it all starts with a very different idea of what makes a planet tick. Let me introduce you to the Hycean planet. The name's a mashup of hydrogen and ocean, and it's pretty much exactly what it sounds like. A world completely covered by a deep liquid water ocean, but instead of a nitrogen-oxygen sky like ours, it's buried under a thick hydrogen-rich atmosphere. The conditions would be totally alien, but maybe, just maybe, perfect for some kind of life. In one of the most exciting potential Hycean worlds out there is a planet called K2-18b. Just try to picture it, a planet where the entire surface is one single continuous ocean, maybe hundreds of miles deep, all under a sky that looks nothing like ours. It's just incredible to think about. Now this is where my jaw hits the floor. The James Webb Space Telescope pointed its mirror at K2-18b. It found methane and carbon dioxide, which totally fits with the idea of a water ocean, but it also found a really tantalizing hint of something else, a molecule called dimethyl sulfite. And here on Earth, that stuff is almost exclusively pumped out by living things, especially ocean life like plankton. Now, this isn't proof, but wow, is it one heck of a compelling clue. All right, so we've questioned whether Earth is the best possible home. We've questioned what kind of atmosphere can sit on top of a water ocean. Now, let's question the big one, the most fundamental ingredient of all. Do you even need water for life?
To explore that, we're going to take a trip to one of the weirdest, most fascinating places in our very own solar system.
Just look at these numbers. They really spell out just how incredibly alien Titan is. We have our comfortable liquid water. On Titan, it is bone-chillingly cold. We're talking minus 290 degrees Fahrenheit. It's so cold that what we think of as gas, methane and ethane, is actually a liquid. It forms rivers, it fills lakes, it even rains from the sky. It's the only other place in the whole solar system with stable liquid on its surface, but it's a liquid that would freeze us solid in a second. So how could life possibly work in a place like this? Well, the chemistry would have to be completely rewritten. Forget breathing oxygen. Scientists have theorized that life on Titan could breathe hydrogen gas right out of the atmosphere and eat a chemical called acetylene, which, conveniently, is created by sunlight and literally rains from the sky. That chemical reaction would actually release a surprising amount of energy, more than enough to power life.
Okay, but every living thing, every cell, needs a container to hold its bits together. Here on Earth, our cells use membranes of fats and oils that work perfectly in water. But in Titan's liquid methane, they'd just fall apart. So a team of scientists dreamed up a totally different kind of membrane they call an azotosome. It would be made of nitrogen-based compounds that could form a stable, flexible little bubble in that super cold alien liquid. It's a brilliant theoretical solution. So we have all these mind-bending possibilities, right? Super-Earths, Hycean worlds, a life swimming in methane on Titan. They're all so incredibly different, which means the way we search for life has to be different too. The clues we're looking for have to be as creative and diverse as the life we're hoping to find. For a world like Titan, the smoking gun might not be some tiny molecule. It might be a huge, planet-wide effect. Remember that theory where life breathes hydrogen? Well, if a whole ecosystem were doing that, we'd expect to see a lot less hydrogen gas near the surface than higher up in the atmosphere. It would look as if the entire planet itself was breathing. Finding something like that, man, it would just be profound.
And that brings us right back to where we started. This whole search for life has become so much more than just looking for another Earth. It's forced us to expand our imaginations, to picture super habitable planets, water worlds with hydrogen skies, and even life that finds a home in lakes of liquid methane. It really makes you wonder, doesn't it? Maybe the universe is absolutely packed with life, and we're just now learning how to see it.